Okay, so let's have a look at this quadratic model in question. So the horizontal cross-section of the widest part of a sail is shown below. The mast is at the origin, so we have this sail that is modelled with this curve here, and it's saying find the quadratic equation to model this cross-section. Okay, so we're going to use the completed the square version to do this. So that's my completed the square version. So this would have a minimum point of minus b, c. So in the context of this, our minimum point here is 100 minus 15. So I'm going to use that to be able to build an equation of this type. So let's start with this. So I've got my y equals, I don't know what a is, x minus sorry, plus b, where b is the x coordinate of the minimum point but with the sign switched. So it's going to be x minus 100 squared, and then the c part is the y coordinate of the minimum point. So I've got minus 15. Okay, so all I need to do is to find what a is, and I have my full equation. So an additional point I know is that this goes through 0, 0. So at 0, 0, 0 equals a times minus 100 squared minus 15. So a equals 15 over 100 squared, which is 100,000. So that equals 0.0015. That's correct, isn't it? That's 1, 2, 3, 4. Yeah. So that's my value for a. So that gives me an equation of y equals 0.0015 x minus 100 squared minus 15. It doesn't ask us for a particular form, so we can just leave it exactly like that. Very happy with that. Okay, so how far from the mast are the points on the sail with a depth of 10 centimetres? So we are after the point down here. I'm after this coordinate here, I'll call that x1, and this coordinate over here, I'll call it x2, where this depth is 10 centimetres, so that y coordinate is minus 10 because it's below the x-axis. So I need to solve that equals minus 10. So I've got 0.0015 x minus 100 squared minus 15 equals minus 10. So x minus 100 squared equals, if I take that over to that side, that becomes 5 over 0.0015. I'm going to do this the longhand way, the algebraic way, so I end up with, let's go here, so I've got x minus 100 equals plus or minus the square root of 5 over 0.0015. So x equals 100 plus or minus the square root of 5 over 0.0015, and we'll work out the decimal values of that. So I've got 100 plus square root of 5 divided by 0.0015. So that is 157.7. I'll go to one decimal place. and these are based on centimetres, just checking the units on this, or x equals 100, or so if I do the same thing with a minus, or 42.3 centimetres to 1 decimal place. Okay. Is this model valid for all values of x? We're only talking about this part of the curve here, so we say no, so x can't be negative, can it? So it must be between 0 and 200, because it just wouldn't make sense if we went beyond 200. It would be coming up, it would come up here, wouldn't it? So that's our answer to that one. What assumptions about the sale does this model make? So I suppose it's, we're assuming that it's following a quadratic model, so we are assuming that the sale is symmetrical about x equals 100. So basically there's this line of symmetry there, that it follows that line. Do we think that's sensible? No, it's probably not. I would imagine that's not the way that a sail works. It'll be affected by wind. It has a constant shape, not affected by wind, which would be a rather strange thing to happen for a sail. So I think they are not sensible assumptions, and we might need to refine the model if we wanted it to be really accurate. Okay.